List comprehensions are one of my favorite syntactic sugars of the programming language Python. They are very powerful and concise and can do a lot of work in a single line of code. However, back in the day when I started learning the language, they were also one of the most difficult concepts to wrap my head around. In this video we will talk about the basic syntax of list comprehensions, and I will also provide some illustrative examples to make sure that after you've watched this video, you can use list comprehensions in your own code. And without further ado, let's head right into the code. Okay, so how would we go about learning about list comprehensions? Well, I guess I would start the best by showing you what list comprehensions are certainly not. Let's imagine that we want to create a list of all even numbers smaller than 10. Somebody who doesn't know about list comprehensions might write the following. We have our even numbers list here, and inside this for loop we iterate over the range of 10, and we say if the number modulo 2 is equal to 0, then we append the number to our list. And if we check the result, we get all the numbers that are even and that are smaller than 10. However, this approach has some disadvantages. Of course, this is a small example, but you can imagine that if the examples get more complicated, we would write a lot of code just to simply generate a list of numbers. The variable number that we use inside the for loop leaks outside of this for loop. I can prove that to you by just saying print number, and then we are able to see the last value of this number. This is something that you don't want because this can introduce bugs. Imagine that your script is a bit longer and you accidentally use the variable number again or do something different with it. We don't want that. So how can we improve this code? Well, we can use a list comprehension. But how do we write list comprehensions? Let's have a look at this example here. The list comprehension basically starts with an opening bracket, and then after that we have an expression. This expression tells us how the elements look like that will end up in our list. And then after that we have a for statement that iterates over an iterable, and in this case our iterable is the range of 10. If we print this, we get all the numbers from 0 to 9. One thing that is cool about this notation is that brackets are already used in Python to create lists. So if you have a regular list, you would define it like this, by using these brackets. So whenever you see brackets in Python code, and even if it's a list comprehension, you already know that the result will be a list. That is all nice and good, but now we have all the numbers that are smaller than 10, but we only want the even ones. So how can we achieve this? We simply add an if statement to our list comprehension. The if statement is something that we can add after our for statement here. You can see that here this condition tells Python that we are only interested in all the numbers that are modulo 2 0. And if we print the result, of course, we only get the even numbers. So one thing that might be confusing when you start learning about list comprehensions is which part does belong where. If we look at the general syntax here, we see that we have an expression that basically allows us to transform the values that go inside our list. Of course, the iterable and the for loop, and then after that a condition that each element we iterate has to satisfy. We can see inside the for loop variant here that the most inner part is basically the part where we append the element to our list. And this is actually the thing that comes first in the list comprehension. So the focus is shifted from how we generate the list to what exactly ends up in the list. So whatever ends up in the append call is the expression that starts a list comprehension. Now we can see the advantages that we get when we use a list comprehension in comparison to an old classic for loop. For once, the code that we wrote is just a single line, so it's less code that we write, which is a good thing. Also, no variables leak into the scope after the list creation. I can demonstrate this by just removing this piece of code here, and then by printing or trying to print the number variable which we use in this list comprehension. And we get a name error, the name number is not defined. Now let's imagine that it is not enough to just put the numbers in our list. Instead, we want to modify the numbers in a certain degree. And this is easily possible by modifying the expression part of your list comprehension. So in this case, instead of just passing the number, as we did in the example before here, we square the number and all the squares will end up in our list. The cool thing about this expression part is that you can do basically anything here. You can get really creative with this and modify the elements of your new list as you wish. By the way guys, if you want to help this channel grow, please consider subscribing and leaving a like. So let's look at another example to illustrate how we can work with list comprehensions and strings. Let's define a variable called sentence that says subscribe to TheCodingBro. Then we can use the split method provided by the string class to split this sentence into words. The words are collected then in a list. Now we want to filter all the words that are shorter than 3 characters, and we can do that by using again a list comprehension. And this time we can see that the list comprehension also works by passing in an existing list. So here again we extend our list comprehension with an if condition, and this time we use the built-in len function to check the length of the word. And the result obviously is that the word to is not part of the new list anymore. Also, there's no need to create this intermediate list. You can just do everything in one bigger list comprehension and you get the same result. The cool thing about strings in Python is that they are iterable. So if you want to split a string into all characters and collect these characters in a list, you can do that by using a list comprehension. And it's really easy. You basically just say, I want every character C in my sentence. And the result will look like this. Even the white spaces are inside of this list. You can even go one step further and say that you only want all the characters in your new list that resemble a digit. And for that again, we introduce an if condition that uses this isDigit function. And our output should now be 9210. Another example would be to collect only every second character of a string. Again, our sentence will be subscribe to TheCodingBro, and let's start by looking at a bad example. In this case, we use the good old for loop again to achieve our goal. As we can see, this code does exactly what we want. We only get every second character in our list. However, we have to define an index variable because we need to check if we are at the correct index so that we know which character has to be appended to the list. And after we appended or not appended the character, we need to increment the index variable. So this is actually not that great because nobody wants to manage these index variables manually. Also, these two variables, C and IDX, leak into the outer scope again, which can again lead to bugs. How can we improve this code? Luckily, there exists a very nice synergy between list comprehensions and the enumerate function. Now, what does the enumerate function actually do? It gives us a tuple that consists of the index and the specific element that we are currently looking at when we iterate over the enumerate object. That means the index variable that we created manually in the example above here, we basically get that for free here, and we can use it again in our if condition in our list comprehension to achieve the exact same result in much shorter code and much more readable code. Another example that illustrates how easy it is to derive new lists from existing lists with list comprehensions is the following. Let's imagine that we have a REST API that provides us with information about certain movies. And the result could look something like this. We have the first movie, Inception, that was released in the year 2010, and it was directed by Christopher Nolan. And then we have two other movies here. So let's imagine now that we are building a UI for this specific API. And some requirements tell us that we only want the name to be released. We also only want it to be in uppercase, and we want to give the user the possibility to query for a release here and for a director. In this case, let's say we only want to have all the movies that were made after 2013 and that were directed by James Cameron. Now we can easily use a list comprehension to achieve this goal. Again, we use the same syntax as we did in the previous examples. We start by the expression, and now we can see that we also do some kind of modification. We basically only take the name attribute of the movie and then also say that it should be in uppercase. Then we specify our for statement. In this case, we iterate over all the movies in our existing movies. And then after that, we have our if condition that basically evaluates the year the movie was made in. In this case, it has to be after 2013, and the director has to be James Cameron. And we see the result is only Avatar 2, because it was made in the year 2022 and it was directed by James Cameron. So it is easy to imagine that we can use this kind of logic to create some sort of query function that would make this condition here dynamic. Depending on the user query, we would have a different if condition. The last feature of list comprehensions that I want to look at is nested list comprehensions. Let's imagine that we want to collect all the possible 3-bit numbers, and each 3-bit number we want to represent by a list of zeros and ones. We can do that by using a nested list comprehension. In this case, the expression part of our list comprehension itself is a list, and a list that contains 3 variables x, y, and z. Because you have these 3 variables here, you also need 3 expressions that do something with these variables, that basically fill in the blanks. And this is why we have 3 different, or rather identical looking, for statements, one for each variable. And if we print the result, we see that we have a list of lists that each contain 3 numbers that are either 0 or 1. We start with 000, 001, and so on. I think the next example might illustrate even more how useful list comprehensions are if you know what you are doing. Not that I know what I'm doing. But anyways, let's imagine that we want to build a chessboard, a primitive chessboard that is represented by a list of lists. And each tile of our chessboard is represented by either this black square, which is just a Unicode character, or this white square. And because I said or, this basically implies that we need to be more clever about our if condition. But let's start at the beginning. Again, our expression in this case is already a list, and it is actually a nested list comprehension that is nested in this outer list comprehension here. So inside the inner list comprehension, we select the black tile, so this is our expression here, but only if the indexes or the sum of our indexes is even, and the first part of this index comes from the inner list comprehension and the second part of this index comes from the outer list comprehension. And we will see in a minute why this is the case. So if our index here is even, then we have a black square. Otherwise we do have a white square. And we repeat this 8 times because our chessboard is a square with side length 8. So let's print the example to see what happens. We get a list of lists again. Each list inside our list here represents a row of our chessboard. And inside this list we have black tiles or white tiles. So let's play a bit with the dimensions here to understand what is happening. Let's say if we reduce y to 5, we only get 5 rows. And if I increase x to go to the range of 10, then the rows get wider. In the inner list comprehension, you can basically use both index variables to do a fancy calculation, and this enables us to alternate between the black and the white tiles. So with this last example, I want to illustrate that you can get really creative with list comprehensions. While I was making this video, I thought to myself, there has to be a possibility to print emoji characters on the terminal. I think obviously everybody knows there has to be this possibility, right? But then I thought, I want to list the first 100 emojis that are in the Unicode specification. With a bit of research I found out that the first one, this smiley face, is represented by this hex value. And after a bit of tinkering I came up with a list comprehension that collects the first 100 Unicode representations of emojis. If I print this to the console, you will see these funny looking strings. These are basically the escaped Unicode representations of the first 100 emojis. In a second list comprehension, where the expression uses the codex module, I can then turn these into real emojis. And the result then looks like this. And indeed, we get a list with the first element being the default smiley face, then the more grinning smiley face, then the one that is crying, which is weird, and also a bunch of other ones that my terminal apparently cannot display. So that wraps up the video, guys. I hope you learned something. Leave a like and subscribe if you found this content helpful. It really helps the channel grow. And I'll see you in the next one. Goodbye.